Dive into the fascinating world of paleontology with a twist. It's like solving a mystery from the past. Imagine being a detective, but instead of crime scenes, you're dealing with ancient clues, logical deductions, and timelines. Just when you think you've got it all figured out, bam! A new piece of evidence shakes everything up. In today's episode, let's rewind to 575 million years ago, post a massive ice age. Picture the deep oceans where something big is happening, complex, multicellular life is making its grand entrance. Before this, Earth had its share of small, single-celled life like bacteria and algae, with the occasional bigger critter. But now, the fossil record is bursting with feathery-looking rangeomorphs, disc-shaped oddities, and maybe early sponges or coral-like wonders like Hautia. Some of these creatures are no joke, almost 2 meters long. This explosion of life is known as the Avalon explosion. It's like Earth's prototype for ecosystems filled with big, complex life. But why did it happen? Cue the detective work. One major clue is the Shram excursion, sounding more like a mystery novel title than a geological event. This worldwide swing in carbon isotopes, recorded in rocks around the same time as the Avalon explosion, raises eyebrows. The hypothesis: changes in Earth's carbon cycle, possibly triggered by a sudden influx of extra oxygen in the deep ocean. Talk about a plot twist in Earth's history. Now buckle up for a plot twist in the paleontological saga. Picture this: a surplus of oxygen reacting with and releasing organic carbon from the deep ocean, like a chemical dance involving dead algae and other organic goodies. This carbon extravaganza gets sprinkled worldwide, leaving its mark in rocks, starring the Shram excursion. The catch? Scientists are scratching their heads over what might have triggered this oxygen surplus in the first place. If the Shram excursion and its extra oxygen are the culprits, it supports the idea that the explosion of life at that time was linked. After all, animals need oxygen, right? More oxygen in the deep ocean could mean more underwater creatures. But hold on tight. Here's a twist hot off the press. A 2023 paper throws a curveball, proposing that the isotopes and the biodiversity boom might have happened without any oxygen increase. Yep, that's a game changer contradicting decades of beliefs. How did they crack this case? They went back to the scene of the geological crime, the Shram Formation rocks in Oman, the OG evidence for the Shram excursion. Instead of just focusing on carbon, these sleuths examined iron and thallium too. Armed with X-ray fluorescence and mass spectrometry, fancy ways to figure out what's in a sample, they made a jaw-dropping discovery. The rocks could only have formed in oxygen-poor water, not the oxygen-rich environment everyone assumed. Hold up, rewind that last part. If it was oxygen-poor, it means the excursion happened before any significant oxygen increase. And if the animals showed up at the same time as the excursion, it means they were early birds, making their debut before the oxygen party even started. Mind blown? Hold on to your hats because we're flipping the script on the timeline. If this new theory holds water, multicellular life didn't need as much oxygen as we once believed. It's like these early pioneers of life faced tougher conditions than we gave them credit for. And they emerged not because the world was comfy cozy, but in spite of its challenges. Now let's be crystal clear. This isn't the only lead in town. Other papers argue that oxygen, our buddy O2, still has a role to play in this ancient drama. So the big reveal to our investigative puzzle is, drum roll, please, we're still in mystery territory. It's a head-scratcher, a riddle waiting to be unraveled. This could be a red herring, or perhaps it's the golden clue that'll shed a whole new light on the case. Either way, it's got us questioning some long-held assumptions. Why did multicellular life thrive in such tough conditions? If oxygen isn't the hero, then who is? Right now, we're in the dark, but fear not. paleo detectives are on the case, determined to crack this ancient enigma wide open. Thanks for watching.